And today we're going to be doing Unit 10, Notes 1. So we're going to be talking about reflections. So basically, whenever you are reflecting, you have something that's called the line of reflection. So if you take a look at this first one, we took this E right here, we basically took it and we flipped it over that line, and that's why we got E on the other side. So if you think about when you're looking in the mirror, okay, the mirror is that line of reflection, okay, and your reflection is going to be actually the same distance from the mirror that you are. Do you ever notice as you get closer to the mirror, so does your reflection? Same kind of idea. So if you look at, so this over here is an example of a reflection across the x-axis. So we took this point and we reflected it here. This point and reflected it here. This point and reflected it here. So what you're actually going to notice is that the pre-image and the image are the same distance from the line of reflection. I'll make that a little bit bigger for you. Oh, that's not working. Okay, so the image and the pre-image. So the pre-image is the first image. So the pre-image is the image before flipping. Okay, so then if you notice that this is 1, 2, 3 from the x-axis, 1, 2 from the x-axis, and 1, 2 from the x-axis. So they're the same distance from that reflection point. So let's take a look at how we reflect some of these things. So first of all, reflection in the x-axis. To reflect something by the x-axis, you need to multiply its y-coordinate by -1. So let's start with the point 3, 4. So we're going over 3, up 4. So to start with, I have the point 3, 4. Now that's my pre-image, my image before flipping. Now I want to take and I want to reflect it over the y-axis. So I'm going to take my y-coordinate, which is 4, and multiply it by a -1, which is going to give me -4. So then I'm going over 3 and then down 4. So now my new image is 3, -4, because I reflected it over the x-axis, which means I need to multiply the y-coordinate by a -1. Taking a look at the middle one here, to reflect a point in the y-axis, multiply its coordinate, its x-coordinate by -1. So reflecting the y-axis, now we're going to multiply the x-coordinate by -1. So let's start again with that point 3, 4. So we're going over 3, up 4. So that gives us the point 3, 4. Then we want to multiply the x-coordinate by a -1. Well, that's going to give us a -3, and then the y is going to stay the same. So -3, 4. So we have the point -3, 4 for that one. Last but not least, to reflect a point in the y over the line y is equal to x. So remember that the line y is equal to x is basically just a line that goes like this through the origin. Okay, so it kind of cuts our grid in half diagonally. Okay, so what we want to do to reflect a point over the x and y axis is to simply flip-flop the x and the y. So again, let's plot our point over 3, up 4. So we have the point 3, 4. So now to reflect it over the point x, or the line x, y, x is equal to y, I just need to simply flip-flop those, which means I have the point over 4, up 1, 2, 3, which is right here. So then I graphed the point 4, 3. So those are the 3 types of reflections that we're going to be doing today. And actually, we're going to be doing each of those reflections with a line of symmetry, with objects. So let's take a look at reflecting this triangle. So we have the triangle ABC. So let's go ahead and plot these points. So the first one we have is -5, 3. So going 1, 2, 3, 4, 5. Left 5, up 1, 2, 3. And I'm plotting that point. So that is point A. Then I'm going over 2, up 0. And that is going to be point B. And then I'm going over 1, up 2, and that is point C. So right here, I have a triangle. And now we want to reflect it over the x-axis. So if you look up earlier on your sheet, recall that to reflect it over the x-axis, I need to multiply each y-coordinate by -1. So y-coordinates are always the second one in the parenthesis. So each of those I'm going to write or multiply by -1. So when we do the image, we designate the image by writing A prime. So the image of A is going to be -5. 3 times a -1 is -3. the image of B is going to be 2, and then 0 times the negative 1 is still going to be 0. So the image of B is the same as B. And C prime, the 1 is going to stay the same, and 2 times negative 1 is negative 2. So let's go ahead and let's graph that point. So we're going left 5 again, but this time we're going down 1, 2, 3, and that's going to represent A prime. Well, B prime is going to be the same as B. So that right there is B prime. Last but not least, C prime is over 1 down 2. So this right there is C prime. So now if we're connecting all of those, we're going here, here, here. Wow, that was horrible. Let's try that again. So we went here to here to here. So if you notice, it looks like we took that triangle and we flipped it over the x-axis. Now let's take a look at number 2. Reflect a square JKLM with the vertices -4, 6. So we're going up left 1, 2, 3, 4. Up 6, 1, 2, 3, 4, 5, 6. So that is this point right here, and that's going to be J. K is over 0, up 1, 2, 3, 4, 5, 6, and that is K. And then M is -4, so we're going left 1, 2, 3, 4, and down and up 2, 1, 2, which is there for M. And then L, I apparently didn't feel the need to graph, is 0, 2, which is right there. So this is JKLM. So now we need to find the image. It wants us to do it over the y-axis, which means we're going to multiply the x-coordinate by a -1. So for J prime, we're going to multiply the -4 by a -1, and that's going to become positive, and the 6 will stay the same. For K prime, when you multiply 0 by -1, it's going to stay 0. For L prime, multiplying 0 by -1, it's going to stay 0. Again, remember that my y-coordinates are staying the same. For M prime, -4 times -1 is a +4, and then 2. So let's go ahead and let's graph these points. So for J prime, we're going left 1, 2, 3, 4, and up 6, which is here. So right here is J prime. Well, K prime and K are actually going to be the same point because they're both 0, 6. Same with L and L prime. They're both going to be the same point because they're both 0, 2 because we were multiplying by 0 there. And last but not least is 4, 2. So we're going over 4, up 2, and that's going to give us M prime. So this right here is our image after we reflected it over the y-axis. So let's talk about this thing called lines of symmetry. So a line of symmetry is a reflection line. Okay, we also refer to the line of symmetry as the axis of symmetry. So objects that have symmetry are going to have lines of symmetry. So, for example, taking a look at part A here, this kaleidoscope, if I were to draw a line right down here, if I were to exactly cut that in half, notice that if you were to kind of fold it over on itself, it would line up. So that means that it's symmetrical on either side. So all I'm trying to do is find lines of symmetry. So each one of these corners has a line of symmetry through it. It's kind of hard to draw on my iPad here. So each of these has a line of symmetry that it's cutting the shape. So if you were to go through and count each of those lines, there's 7 lines. So yes, it does have lines of symmetry, and there's going to be 7 of them. Taking a look at part B, a lot of times circles have infinitely many lines of symmetry. However, take a look at the shapes that are drawn there. If I were to cut that this way, notice how like this circle over here isn't over here. So the shapes that are drawn in the design are not symmetrical. So no, this one doesn't have any lines of symmetry. Taking a look at this next one, state whether the figure appears to have lines of symmetry, right? Yes or no? If so, state their number. So when I cut this triangle, I usually start by trying to cut it in half. So if I were to cut it in half, hopefully more precisely than that, if I were to cut it in half, notice that it's the same on either side. Well, it's the same if I cut it in half this way, and it's the same if I cut it in half this way. So think of it, if you were to fold it on that line, would the ends line up? Would it be the same if you were to fold it over? And for each of those, it would be, and there were 3 lines. So now we need to figure out if this parallelogram does. Well, if I cut it down here, if you were to fold it over, this corner would be way over here. So it doesn't have a line of symmetry that way. It also doesn't have a line of symmetry this way. If you were to fold it up, this corner would end up here. So that is not a line of symmetry. But where we do have lines of symmetry is going through the diagonals. Those are going to have lines of symmetry when you fold it up. Okay, so yes, there's two lines of symmetry. Taking a look at this trapezoid, we want to state whether the figure appears to have lines of symmetry. So first of all, we know we can't cut it in half horizontally, right? Because the top is smaller than the bottom. But we can cut it in half vertically. And when you fold it over, the ends will line up. So yes, this one does have a line of symmetry, and it's only one line. Last but not least, we want to find the line of symmetry for this butterfly. So if I were to cut this butterfly down in half here, it would be symmetrical on either side. We can't cut it in half that way because it won't be symmetrical on either side. So this one only has one line of symmetry. So that concludes your note video for today. Go ahead and show me a completed note sheet and I will get your worksheet. Thanks for listening.